Hi everyone, I'd like to welcome you to our 25th Masterclass. Today we're going to be doing a special tutorial on using a tool called ShaderForge. Now ShaderForge is a free utility for Unity. It used to be a paid utility that cost about $100. It was on the Asset Store, but the creator has rather nicely made it a free product now, and we're going to actually dig into the details of building your own materials and shaders using the ShaderForge utility. Now I'm just going to go into my project. Now I've got a different project open this week. I've just got the desert wall scene that I was building quite a while ago, and this is partly because I've been fixing it over the last couple of days just to get it actually uploaded. But we'll use this as a demo scene for building some custom shaders that we can play with in here. So the first thing you want to do is you want to go to the window menu and you just want to pull up ShaderForge, which is just here. That's after you've installed it. So it's actually in the Asset Store. You just need to download it and install it through there. And we're going to begin making some interesting shaders using this utility without actually going into the code itself. Generally speaking, the code for these kinds of utilities tends to be pretty messy. You don't really want to edit it yourself. Sometimes it can be documented, sometimes it can't, but for the sake of today, we're actually going to go completely with ShaderForge and work with that. So I'm just going to create a new shader. I'm going to create it in here. I'm going to call this ShaderForge. I'm going to make a hologram first, because that was a nice little demo of making a custom shader. So I just picked the lit PBR template there. Now that means that it's going to respond to lighting accurately. Metals will look like metals, non-metals will look like non-metals, things will reflect, and all those bits and pieces will stick together and match the existing layout in Unity. And as you can see here, as soon as we've fired it up, we've got a preview of our shader in the corner here. And we've got a basic sort of setup for it on how it's supposed to look. And if we scroll out of it, you can sort of see all the bits and pieces. So I'm going to make this bit quite big so people can actually see what we're doing. Now the first thing we want to do is with a hologram, we want to actually make this transparent. And we're going to actually set that in the settings here. So I'm going to ignore all these bits and pieces. Shader settings, lightings. Should go with deferred. The roughness. Blending. Should have an option for transparency. I'm just going to dig that one out. Maybe it actually will be that way already. Transparent mode. Whoops. Sorry. Okay. So the first thing I'm going to do is I'm going to right click, and when you right click in here, it'll actually bring up all the properties that we want for our hologram. Now the big thing we're going to play with is the emission field. Emission basically means the amount of light that this shader emits on its own, and for things like holograms and neon signage and those kinds of things, the emission field is your friend. It will make sure that it is bright regardless of the outside lighting conditions, and if you're using baked global illumination, then the baked lighting will be actually impacted by these shaders potentially if the object is static. So first things first is to get a hologram effect. There's a couple of combinations. There's a series of lines, usually that sort of animate up and down. Then we have what's called a Fresnel lighting. That is, it makes it bright around the edges of the model. And to do that, we've done that in code in a previous tutorial we did on building shaders using a text editor. But since we're doing it from here, I'm going to recreate that same effect. So that actually has some of the camera controls, and it's got some math functions that sort of define that one. So I'm just going to grab some scene data on, we need the view angle, I think, if I'm remembering correctly. We want the dot product. It's one of our key products here. We've got the normal, come here, normal direction. I think it's the view direction, yes. So we've got the normal direction there, we've got the view direction, which is the angle of the camera. As you can see here, these little items indicate what we've got. So I'll just drop that into there, put our dot product there. Okay, and now the next thing we're going to do is we'll actually make this scaled. So what we're going to do next is we're going to add a power operation, which is going to be an arithmetic. So we're just looking for power, and that's just the same as putting something to the power of whatever, so squaring, etc. We're going to exponent. So we just need a user input slider here. I just need to find where the bit is for it. Copies, slider. I call this room strength. rim, just the rim. Okay, I'm going to move that one around. I'm just going to put that up to there. Okay, and I'm going to multiply that by some colors. So I'm going to put in a color operation. A property, color. This is going to be our rim color. Alright, so I'm just going to take this, sorry, I'm doing a multiplication again. Just going to multiply this color by this power. I'm going to send that one out through to the emission field. Now, first things first, our color is a bit dreary, so I'm just going to change that to red-ish. I'll make it actually a bit more orange. I'll take away that blue. Okay, so we've got quite a strong looking one there. Now, the next thing we're going to do is the rim power. I'm hoping that lines up nicely. So that's like 6. Just going to put down Skype so I get random messages popping up. Okay, so we're seeing something here. I'm just wondering if I am doing something wrong here. What I may do is I may just pop into the Unity shader reference for 1 second. Where's the surface shaders? We'll just look up the Unity surface shaders manual, which is always a really great way of getting some samples on surface shaders. I'm just going to make sure that I've got this data correct. So I'm just going to scroll down to one of their rim lighting examples, which is this one here. And that one is just the normalized view direction. So I'm just going to get the view direction and normalize it. So normalizing it just means clamping it to a particular range, specifically that no individual variable will go above 1. Or if you want to be pedantic about it, the length of the vector is 1. Again, you don't need to worry about this too much. This is pretty much a visual operation. So I'm just going to find the vector, normalize. Just going to normalize that view direction. Put that into there. There we go. Now, which sorry about that. Looks like I just lost internet for a second. Hopefully everyone is back to normal. I actually have not advanced the stream, so we're just looking at the nature of the normals correct. That does look correct to me. The only other difference between this and the sample is the saturate and the 1.0 minus, but I don't think those particularly matter here. So I'm going to take away this normal map just for a second. Whoops, I forgot to hit the compile shader. That always helps a little bit. And I think our thing here is going to look quite a bit different. Yes, it is. So now as we play around with these values, there we go. That's what we wanted. So I'll tick on the auto just so our changes are automatically compiling. So as you can see here, that we've got the rim being darkened instead of brightened, and that's because we just need to flip the order around. And that we're going to do here on this dot product. So the first thing we're going to do is we're going to subtract from 1, and then we're going to clamp to 0 to 1. So do that, and there should be a 1 minus. There we go. Just go for 1 minus. Okay, this is just going to reverse the order. So I've got ding, 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 and ding. Give it a second. Thought I had that right. Okay, there we go. So now we've got a hologram on the first steps of it anyway. And then we can use this power field to change exactly how that looks. Okay, so what have I done now? Whoops, made a mistake. we should be going into there, not there. And we should be going into there. Let's give it a second. Thought that was odd. Okay, so now we've got something that'll do that. First steps first. Okay, I'm also going to organize this a little bit. One of the things when working with node-based editors like this is they very quickly turn to spaghetti. So what I'm going to try and do is just organize all the related fields in a way that makes actual logical sense. So push the normals back there in the dot product. Grab U. You sort of just want to make things look like they feed into the results in a logical way. Otherwise, you do end up with spaghetti, and that doesn't make much fun when you're trying to debug something and figure out where a problem is. Okay, so there we go. That's our first property. Now the next thing we want to do is want to get some animated glowing lines here. Now I don't know if I've actually got any line textures in here, and we're going to have a quick look. Use, you look like we've got one there. I think that's just on the alpha channel. Yep, that will work. That would work too. But lines, yeah, you look like you could work. Okay, so what the next thing I'm going to do is I'm going to add a texture. And we're going to replace this rim color with something a bit more interesting. So the first thing we're going to do is we're going to add a texture. So we're going to add texture 2D there. This is going to be our lines. And I'm just going to select lines 2, alt that one there. Okay. Now we need to select a UV coordinate. Now there's a couple of ways we can do this. We can do it using the model's geometry. Alternatively, we can use screen space. Now the difference between the two I'll show you, but it will make a pretty big difference. So these lines, we're going to grab another multiply. We're just going to multiply that color by the lines. Okay, now it's actually not going to do anything because we don't have, as you can see here, this won't work because the UV is missing. Or if it is, it'll use the object UV. Right. It is using the object's UV. So what we'll see here is that this will be affected by the object's internal UV mapping. And if I make this brighter, in fact, I'm going to grab the... no, I will leave it like that. But what I will do is I will add a multiplier onto the multiplier itself. So we'll just add another multiplication operation. Stick U in there and there, and then we're going to add a property, another slider. This is going to be our HDR multiplier. What I mean by HDR multiplier is that when you think if you've been working with digital graphics for a long time, but you sort of haven't done anything recently, you tend to think of colors being within the range of black to white. And that means you've got sort of a constant range, which is usually represented from the numbers 0 for black and 255 for white. When you work with HDR, you actually start working with values that are brighter than what we would consider white to be. So you might have a red that is above and beyond 1.0 on the red channel. And what that typically does in 3D engines is we typically use that for bloom. So you get sort of bright glowing objects when they're really bright. So when you look at a light source, don't look at the sun, but if you do, you'll notice that there's sort of a flaring on the outside. Even when you do it with cameras and things, particularly there'll be light bouncing around the camera and so forth, that's bloom, and that's caused by particularly bright light sources. Likewise, if you're using baked lighting, such as using the built-in Enlighten or the progressive light mapper, HDR surfaces will emit light onto other surfaces. Even non-HDR ones will, but they're particularly bright with the HDR stuff. So what I'm going to do is I've now got this slider, and I'm going to set the sliders, the multiply's value up to 20. So I'm just going to be able to drag and make this quite extreme. And as you can see, we can now make stuff that is obviously clearly looking brighter than the edge. And when we put this into a scene with a camera, we'll actually be able to get that to bloom as well, particularly around the edges there. Now, this hologram is trapped with the UV that's already on the object. So if I swap this around with some, what have we got? This is the SF sphere. I will come back to this test object in a second, but if I grab, for instance, that, you'll notice that the UVing is not quite the same anymore. We've actually got the stretch marks and things on the object. And that's not a particularly good effect when it comes to holograms. So if I'm going to swap this with something similar. I might even grab our own base models because they're a particularly good example of UVing going all over the place. So I'll just try and find our 2017. Oh, maybe I'll do we have a one? It's been rotated sideways, but maybe we won't use him specifically. We've got the females. She as well. So I'm trying to find a nice preview object that's got a bit of complexity to it that will showcase UVing problems. This will do. So you can see here, for instance, we've got sideways as well as vertical. So one of the things we'll do is, first up, is we're going to change how these lines appear, and hopefully I am recording these incidentally so that if there is a problem, then I can re-upload it later. So to change this so that lines aren't so sideways, we're going to use the scene UV, and that should come in to dig out the one that has got the screen space position. So screen position, there we go. So I've got the screen position there, which I can express as a UV. I'm just going to drop that into the lines textures UV. We'll give that a second to update. Now this is probably not going to be a particularly useful one because, oh, actually it's not too bad, all things considered. We just don't have much of a control over how the texture is tiling here. It's very fine. So what we can do is we can add a multiplier again. And I'm going to do this with another slider. This is going to be our lines tiling. Make that even a little bit bigger just so we can get a better side of this. So now we've got a zero tiling. Obviously it's not visible, but we can now, for instance, control the width of those. Now that's still not doing really what we want yet. We'll get there. One of the things we want to do is consider perhaps making this animated. So what we can do there is we can start doing vector operations. So I'm going to do I think it's a combine vector, but there in fact is even a panner. That's nice. So I'm going to put that in there. I'm going to put that in there. We're going to add a time property here so we can actually pan the texture along the, I guess it'll be the V. So I'm going to add time. Just have to have a look around for this one. There we go, external data, time. And I'm going to add time t. I'm not sure it's actually doing much. Might be, but it could be very slow. Very, very closely at this one. No, I don't think that's actually doing that one. That may preview actually in the environment. I'm not 100% sure if we'll be able to see that one until we actually hit play. We can. Oh, we do have animated materials. Oh, hang on. It did update for me. Maybe it is just very, very slow. Let's try t times 3. So that one is infrequently updating, but it is. is nonetheless updating. So that will be a useful thing when we actually see this one previewing actually in the environment. Now, the base color there is quite bright. I'm going to pull this one down to blacker. We may want to look at changing how the transparency on this one works. Something to consider is potentially doing a blend mode of additive. Now, additive blend modes basically add to the previous elements. So if you're used to Photoshop, the screen effect is similar to additive texturing. Additive shading. So it'll only ever make something brighter. But for holograms and things like that, that can be the best way of doing it. But if you're working with particularly bright scenes, like an outdoor or daytime scene, then you don't want to go down that path. You probably just want to go with pre-multiplied alpha. Now, alpha blended pre-multiplied is the PBR equivalent, and so it does glasses and things particularly well, as you will see. One of the things we will, though, note is that complex geometry like this, you'll get order issues. So as you can see, some bits are rendering over other bits. That's a downside to working with alpha blended, and that's somewhat unavoidable other than splitting the object up into multiple pieces they render. Okay, so leave that alone. Now the perk of that is that we still keep the transparency, we can still manipulate this around. Okay, I am actually going to go with, I might leave that alone. Okay, so I think we've got our basic shader there. One of the last things we want to do is just be aware of the internal names here. As you see, when you mouse over something, it'll give you internal names for what the objects are. Some of these properties, like for instance, underscore main text and underscore bump map, those are standard names for shader variables. And if you are working with the clothing system or you're working with patterns, you will want to pay attention to sticking with those names. So you won't want to stick with underscore main text, you will want to stick with underscore bump map and those associated texture names, because if you don't and you make your own ones, they won't be compatible with the pattern system. So just be aware of that when you are working with them, that we do follow the Unity standard naming there, and if you are writing custom shaders, you will want to stick to those names. Those names can be found on the Unity website. We're working with shaders. If you search for Unity standard shader property names, you will find a big list of all the common ones. However, these tools tend to use the default names when they build a blank project for you. And the only real ones that you'll probably be working with are the underscore main text and the underscore bump map, which are right in here by default. Okay, so we have got the basics of our shader here. I'm not 100% sure we'll need to do a whole lot to this one, but I am going to expose, so we've got the gloss and the other bits and pieces exposed here, but I'm going to expose just the alpha and make sure the opacity comes through. And I'm just going to set that off do a splitter if I can do that. So to do a vector. Component mask, yes. Okay, so I just need to take him out of him. Split the outputs here, which will probably be under the one I want. Okay. Check this one. If you right click on a node instead, it will give you the details. I do want to get the component mask. It's fine. Ah, I see. I just need to use the. So I don't want the alpha channel on this one if I can. I guess maybe that's not being shown there. Alright, so what I'll do is I'll just duplicate that multiply. I guess that's why. So I'm just going to take the alpha property of the base color, the alpha color, and multiply those together, and I'm going to use that to wire up the opacity. Okay, and that means we can now compiles, tweak that, for instance, the default to there, and just change the overall layout there. Okay, so we've built ourselves a hologram shader. I will put this on an object and we can take a quick look at it. So, what did I call this one? Shader Forge hologram. Okay, so I'm just going to grab a tree. I used one of these last time as well. I'm just going to find a nice one that will do the job. You will do. Wait, no, you won't. Won't use one from the tree system. Or using Unity's tree system. Where are you? You might do. Yep, okay. So let's grow this tree. So we've built a nice set of shaders for this. I'm just going to first. I'm going to start with these leaves. So I'm just going to duplicate this material. Now, if you've used the same property names as the Unity standard ones, when you swap a material around the place, you will be able to, when you swap the material names, you won't have to re-input all these textures because they'll just map from one to the other. So I'm just going to go Shader Forge hologram. You see we've at least got some of these properties back. I'm just going to drop this into the, okay, they're all individually modeled leaves. 1 second. So, was the trunk I'm editing. So as you can see here, we've got the animation effect going on. It's actually scrolling through quite a bit. And otherwise looks kind of normal. Now, the other thing we can change is the base color. We can set the opacity down. So got this. I'm going to make it match the orange effect there, and I'll set up the rim color as well. Now this rim speed is a bit fast. Nonetheless, that sort of works, and we'll just duplicate one of these branches as well. Now the branches have got some sort of clever effect on them as well here, which is a vertex shader, and that's what's actually making them blow in the wind. I don't 100% know if we can do that in Shader Forge, but we're going to quickly find out if we can do a simple vertex shader pass, because if we can, then that's an easy effect to show off, and holograms in particular are a great one to do with vertex shader bits. I'm just going to grab this Shader Forge hologram. I'm going to grab my tree leaf branches and drop them into there. Now this is making me wonder a little bit about the setup of this, because the tree there does not seem like it's got the opacity there. That must be where the opacity is. So into that. There we go. Okay, so one of the things we're noticing probably here quite a bit is because this has used alpha transparency, that the bits that aren't transparent are still showing. One of the quick ways we can get around this one is using the clip shader. As you can see here, we've got a property down here called opacity clip, and that means it's actually going to cut and stop drawing if it's below a certain value. So the clip, I'm going to drop the, I'm going to do two things. I'm going to add a slider again. This is going to be our clip. and we're going to grab the where did we grab it from? This is our transparency one. We're just going to subtract the two, so I'm just going to do a simple subtract. I'm going to subtract from there. I'm going to subtract the clip value, drop that into the opacity clip. Or perhaps the wrong way around. Have a look. Okay. So the tree trunk there, the clip might be set to too high. Perhaps on this one I've got it the wrong way around here too. Maybe it's add. It's one of these things. Okay. So that one's better. That looks right. Okay, so now we've got our hologrammy tree. Again, not the world's best looking shader, but it's a start. And I may just throw this directly straight back into additive. Just have a look at how it looks. As I said, in bright scenes, doing it this way can be a problem. In dark scenes, this works better, but in bright scenes, this does have the downside of not looking quite right. I guess we'll go back to the multiplied alpha, and I'm just going to play with it a little bit until we can get an effect that looks, roughly speaking, what we want. Okay, so one of the big problems we've got here, I guess, is these back faces as well. So we actually might want to disable backface culling, so it renders two paths. We can do that by changing this culling to double-sided. Again, just give it a second to compile. Now, this may break the trunk of the tree as well, but we'll just have a look at this. Okay, it's not too bad actually. A little odd, but that's okay. Alright, so we just want to, I do want to play with the base color here. It's not on that, on the leaves, which is quite dark. Yes, that's part of the problem here. Green. Okay, so I mentioned before that we have the ability to see the HDR preview. So I've actually got a camera in here, which if I turn on, should give us previews of with shaders, shading and things attached. And this is obviously how the scene is supposed to look when it's actually viewed in world. And as you can see, our HDR brightness is quite extreme now on this particular section. So I'm just going to pull down the HDR multiplier from 13. No, you're good. I want you down up. But on you, I'm going to pull you down. I might want to play with, again, these colors a little bit just to... And there we go. We have built a custom shader relatively quickly that has some unique effects and things attached to it. Relatively straightforward. Now we can play with some of these settings. What we've done here with, for instance, the rim lighting is not the only way of computing these effects. What we've done, for instance, the view direction input, we can play with a couple of other variants here that give us interesting results. So we can do view reflection direction, which is similar to the normal, but not quite. You probably really want to be looking at the trunk of the tree, in fact, in this particular case. You can see we've got a much more interesting result that actually even seems to be taking into account the normal map attached to the object. What we're not seeing though is on the tree leaves itself, the result there. And I'm going to take the opacity on these guys. Whoops. You aren't going to leave up, but I'm going to bring you right down. Quite an interesting effect we can have in this one. Now the perk of doing this with the alpha blending again and using HDR lighting is that this is still looking okay even in a particularly bright scene. We're getting quite a lot of interesting looks off this. I'm not really happy with the blue texture there though. I guess that's because it's coming off there. So there we go. Now those are in sync. So if you're a budding VFX artist, this is a great way of getting started. Build all sorts of cool things, and when you combine this with shaders and other bits and pieces, lots of potential for neat effects. Okay, so that is the first shader we'll build. We can do subsequent shaders for slightly more detailed effects, but I think the basics of here you guys should be able to get started with. It's not terribly hard to do. Key things to remember: these green ones are properties. Properties are exposed to the user. So when I look at, for instance, this material, the properties are now listed on the side. So we've got our rim color and all those bits and pieces, which correlates with these green elements on the shader graph. The other ones are all just individual mathematical operations. They kind of do map out to what you would do as if you were writing the shader yourself, but the benefit of the node-based designs is it's very quick to add them to the sheet and then mess with them. On the sidebar, you've got all your various properties. I can go over a few of these individually. So we've got the lighting for the render path. We've got forward and deferred. When you're working with transparency, you want to work with forward. When you're working with non-transparent objects and things, you want to work with deferred. I think these may even just apply to the preview up here, but you will find that you can't use forward shaders in transparent shaders in deferred. The lighting mode is set to PBL, which is the physically based lighting model that Unity introduced in Unity 5. The specular mode. Now there's two modes if you've worked with the standard shader. You've got the specular and the standard. Difference between them is basically what programs you use when editing the files. The metallic workflow is probably the easier one to work with. The specular one is more powerful, but it's easier to screw up. And most tools have been defaulting to a smoothness / metallic model for a while now. Gloss mode, that's gloss versus roughness. Unity uses gloss, but most editing utilities that work with other engines, like the Unreal Engine, use roughness. So if you want to switch those around without having to manually invert your textures, that's a good way to go. We've got the transparency mode, which is the fade versus reflective. So that's actually showing glass versus pure transparency. If I flip that on, you'll see a difference, particularly on this preview model, or you should. You should see more of a gloss effect. So it looks a bit more like glass when you do it that way. I'm actually curious how it looked, how it changed. In here, yes, we've got a little bit less of the background there. Energy conserving will be ticked when using PBL, because you can't avoid that. Light count, if you have only one directional light in your scene, then switching that to single direction will give you a small performance boost in your shaders. It's probably worth discussing shader performance a little bit. When you're working with newer graphics cards, let's say you're building a scene that's really optimized, people have got new computers, you're pulling out all the stops, you're using high-end details and things like that. Things like shader complexity don't matter as much, but when you're working on older hardware or you're targeting people who are using laptops or a wider audience, you kind of do want to tick off as few features you're actually using. Multi-light is probably the realistic approach, especially if you're working with deferred, where it's basic, the cost is effectively free. Where you're working in forward, then there is a cost for additional lights and things. Light maps and light probes are worth having enabled. If you're working with clothing, you definitely want to have light probes enabled, because we use them on the default avatar. The meta pass there is to make it compatible with the Unity built-in light mapping system. So if you're not using those anywhere this shader is going to be used, then unticking it will give you a small cut to the shader size. Reflection probes support all those bits and pieces. Again, if you're not using these features and there's no case where they would be used, if you're making furniture or clothing, don't assume that there is no case where they'll be used, because there's a good chance there is. Then untick them just because there's a performance benefit to doing so. Now, face culling, that basically indicates whether to only render the front of the object or the back of the object. When you're working with transparency, then sometimes rendering the back of the object is important. Particularly if you're working with things like hair, often you want double-sided rendering enabled there. So that's just the face culling mode. You can also set it to only show the back of an object instead of the front. Again, these are sort of stylized effects that might be useful for particular things. I'm not going to go too much more into the details of these things, but you can poke around with them and play. The only other one that's worth noting is just the blend mode. We went through sort of the additive and screen and multiplicative and things modes. They're just useful for building things. You've also got the option to build custom ones. You can see here we've got the source field. If you combine these fields in various ways, you can create things like negative shaders that subtract light from the scene and various other cool little bits and pieces. Oops, I think I've just changed something, so my shader may break. Oops, okay, there we go. I don't think we've got a subtractive, yeah. So you can actually poke around with those settings. If you look them up, they're actually part of the OpenGL specifications when they're originally defined. You can find out what the source and destination combinations are. It's definitely better to do a lookup than actually try and figure them out, because God knows they can be a real pain. Okay, so that covers those shaders. The last thing I'm going to do in my last 15 minutes is actually talk through another feature that's part of Unity called the physics debugger. And I'm doing that because it's a feature that I have used very recently to solve some issues with this particular scene we're looking at, and it is a useful bit of information to know. So one of the things I did when I first uploaded this scene, if many of you watched me build it, was that I actually forgot to add mesh colliders to a large percentage of this scene. So when you walked off this cliff, you fell underground. Likewise, this whole thing fell you through. Now, I have already fixed this scene, but what I will do is I'll show you actually quick ways of finding out where problems exist in the scene using the physics debugger. So first things first, I'm just going to go to the window physics debugger, and it opens up a little window or panel. I've docked mine in the corner here. While the physics tab is highlighted, you'll have this extra little option to be able to see things in the scene. Now, I'm going to break the scene slightly, so we've got something to look at and quickly be able to find and fix particular elements of the scene. So I'm going to take off that mesh collider there. Now, if I'm an avatar walking through here, I don't want to be able to walk through that solid object. It shouldn't be something that's walkable. But finding out before you upload which objects are available or not, and which ones are sort of set up correctly or not, can be a bit of a tedious process. It often requires walking around the scene and figuring out problems. The physics debugger actually makes your life a lot easier. First thing you can do is you can tick on collision geometry here. When you tick on that, you'll actually get a view of the physics interactive surfaces in the scene. They'll get colored. So you can see that all these bits and pieces are solid and can't be walked through, except for this bit, which does not have a physics collider attached to it. And one of the things we can do is we can just click on it. I'll go back down to the object, and we can add a mesh collider or turn one on, and then suddenly it's nice and highlighted. And that again makes life easier for developers who are working to make sure that, well, not just developers, but you guys as well as end users and things, just make sure all your physics colliders are set up correctly. So here we are. This is one actually I missed in my earlier pass, so I'll just do this. Collider component, mesh collider, and I'm going to leave this one as is. So that will cover sort of quickly finding problems. Another problem you might say, and this is one that I found with a customer's region a little while ago, was that they had left a box collider inside the scene, and it was an invisible box collider. So I, for instance, I'm going to turn off this collision geometry, but they had an area that couldn't be walked into the scene, and they couldn't figure out why. In fact, it was a little bit more extreme than that, but the avatar was popping out the side of a particular area because they landed inside the collider, and as soon as they moved or bumped into something, it sort of popped. So they had something that sort of looked like this. I'm just going to take the mesh renderer off. So offhand, you're not going to be able to find that object. In fact, if it's lost in your scene, you've got no idea that's there until you try and walk into an invisible wall. The collision debugger again gives you the option of actually seeing it. Unfortunately, when I sort of click on it, you'll see that I click on the terrain behind it. It won't let me click on it. The mouse select option, when it's ticked, will actually let you select colliders under your cursor. So I can just click that one, find it, and hit delete. And it's gone from the scene. That is another quick way of just selecting the colliders in a scene. A rather useful tool. Okay, I'm probably going to finish up the tutorial there because we got the key bits we wanted to cover done. But I look forward to seeing you all in the assembly region in about 10 minutes for my usual office hours. I've got lots of cool announcements and things to talk about this week. So I look forward to seeing you there. Thank you all for watching, and I will see you all next week.